Hello, my name is Victor Sanchez, and today we're going to talk about the 5 kinematics of the deadlift. Today we have Ali, who's going to be our volunteer performing the deadlift. So the first kinematic is time. The time performing a deadlift is variable, but it's just really essential that the hips and shoulders rise at the same time so that we can maintain that neutral spinal plane. So we're going to have Ali go ahead and demonstrate one deadlift, and we'll count in seconds. Go ahead. 1, 2, 3. So it takes her about 3 seconds to perform the deadlift. So that'll be more important later in calculating velocity. The next thing I want to talk about is position. So for this demonstration, we're going to focus on the concentric and lifting phase of the movement. So go ahead, Ali, and get to the bottom stance there. So as you can see here, hips are loaded, her knees are flexed, and we have plantar flexion at the ankle. And all of these joints are going to be extending in the sagittal plane as she completes the movement concentrically. So the hips are going to extend, the knees are going to extend, the ankle performs plantar flexion, which is also like extension of the ankle. And then the spine is actually going to maintain maintenance of extension. So go ahead, Ali, we're going to do one more. Perfect, so she comes to extension, the hips come to extension, the knees go to full extension. And then for the hip joint, we have her gluteus maximus, that is the agonist performing the movement. At the knee, we have the rectus femoris, or the quadricep muscles in the front. At the ankle, we have the soleus, which is just under the calf here. And at the spine, we have the erector spinae, which branch off the vertebral column, and the rectus abdominis acting as the antagonist to keep that core and the abdominals tight. So go ahead and go face forward. So that covers the position. The third kinematic is going to be displacement. So here from the bottom position, we measured with the tape measure earlier. We had 0.08 meters here from the ground to the barbell. And then when she comes up, go ahead and come up. So from here we had 70 centimeters, or 0.7 meters. So the difference in displacement there in the barbell path from one point at the bottom to its point at the top where the hip joint is was 0.62 meters. So if we use the velocity equation, which is the fourth kinematic, is distance over time. So we take the 0.62 meters, which is the barbell path, and then we divide that by the time it takes her to complete one repetition, which is 3 seconds, and it gives us a velocity of 0.21 meters per second. However, velocity is a vector, and vectors have quantity that include magnitude and direction. So as the barbell rests on the ground, it rises 0.21 meters per second superiorly or north. It comes up. And the last kinematic I want to talk about is acceleration. So if Ali is performing one repetition, her acceleration is not going to change. So you want her to keep a constant velocity as that bar is coming up to maintain a neutral spinal plane and make sure that everything is moving smoothly. Acceleration is really going to be a factor when we change the load on the barbell. So the equation for acceleration is a change in velocity over time. So naturally, if we were to put more load on the barbell, it would take her more effort, more time for her to elevate and concentrically attract the barbell up. So those are the 5 kinematics of the deadlift. Thank you, Ali, for your participation.